Dear students, let us see the problem on the design of a journal bearing. This is very, very important problem. Okay, let us see. Design. Design of journal bearing. For a centrifugal pump, here they are given the application centrifugal pump from the following data. Load on the journal, they are given the load, that is W 20,000 newtons. Speed of the journal, they are given the speed N is equal to 900 rpm. And type of oil is SAE 10. Here oil is SAE 10. That is Society of Automotive Engineers. For which the absolute viscosity at 55 degrees centigrade is 0.017. That is Z value 0.017 kg per meter second. Sometimes the same value can given as Pascal second. Both are same. Pascal second or kg by meter second, both are same. And the here viscosity at 55 degrees centigrade, that is the operating temperature, that is 55 degrees centigrade the temperature given, that is oil temperature, that is TO 55 degree centigrade. And ambient temperature of oil is 15.5, that is ambient TA 15.5 degree centigrade. The maximum bearing pressure for the pump, here they are giving the maximum pressure P max is equal to 1.5 Newton per mm square. Calculate also mass of the lubricating oil required. They are asking the mass of the lubricating oil. If rise of the temperature of the oil be limited to 10 degrees centigrade, that means delta T, that is 10 degrees centigrade. And heat dissipation coefficient, that is K. Sometimes you can use C, both are same. Okay, that is 1232 watt per meter square degree centigrade. This is the given data. Okay, let us see the problem. First, they are asked the design of the journal bearing. Generally, in design of journal bearing means, okay, as you know, if you take any bearing, okay, it is like this. Okay, so bearing. Here generally is just riding contact bearing. So here you have to find out in this what is the diameter. What is the diameter of the bearing, and what is the length. What is the length? First, so here you have to find out. In design means you have to find out first diameter, after then length, then pressure. What is the maximum pressure? How much pressure it may stand. After that we have to find out the condition of the lubrication. Condition, that means which type of oil you are using. Generally you have hydrodynamic and hydrostatic condition, and also you have a thick oil and thin oil. So what type of oil you are using, what is the condition? So you have to find out the condition. You have to find out the condition and also type of the oil. Okay, and also you have to find out the heat generated and heat dissipated. What is the heat generation? How much heat generation? And what about heat dissipation? How much heat is dissipated? Okay, here the heat dissipated should be, heat generated heat should be dissipated. That means maximum heat should be dissipated to the atmosphere. Generally heat dissipated and heat dissipated is same, then there is no artificial cooling. Otherwise artificial cooling is required. That means you have to find out the artificial cooling. First you have to check whether the artificial cooling is required or not. You have to check artificial cooling is required or not. You have to check. Okay, after then, here they are asking the mass of the lubricating oil. So up to now the design is over. Design of journal bearing means you have to find out first what is the diameter of the journal, what is the length of the journal, okay, what is the bearing pressure, what is the condition, or what are the type of lubrication, and how much heat is generated and how much heat is dissipated, and you have to check for the artificial cooling is required or not. So this data you have to find, right? Let us see one by one. First, to solve this type of problems, you have to refer the data book. Okay, let us see the data book. This is data book. Okay, in the question they are given the centrifugal pump is the application. This is the application. Okay, this is the design data for the different bearings. Okay, so you have to check the names. Here we have a centrifugal pump. So our application centrifugal pump. So you have to refer this data. So here we have that is the maximum pressure, that is 0.7 to 1.4 units are mega Newton per meter square. Mega Newton per meter square or Newton per mm square, both are same. Okay, but here already they are given the maximum pressure, that is 1.5 Newton per mm square, that is 1.5 Newton per mm square. So they are already given. So suppose if they are not given some type of, for some problems they may not given the maximum pressure. For those cases you have to consider this value. So here they are given, so no need to consider, no need to take this value. If they are not given, you have to take this value. After you have a suitable Z value, no need, and Zn by P value, Zn by P value. Okay, here you have to take the Zn by P value, that is here Zn by P value is 29.01. okay, and also you can take the C by R value, C by R, that is the clearance ratio 0.0013. this is the clearance ratio, and you have to take the L by D ratio, that is L by D ratio, that is 1 to 2. okay, so by using this data you have to solve the problem, you have to design the problem. This is the Mahadevan data book. Okay, right. So as I mentioned earlier, first you have to find out the diameter and length. Here they are given the L by D ratio, that is 1 to 2. So let us choose the, let us take D is equal to, you have to assume D is equal to 100 mm, that means 0.1 meters. Sometimes they mention the diameter, sometimes they mention the diameter, but here they are not given. You have to assume the diameter. Okay, so from this diameter now you have to choose the L by D ratio. So diameter is over. After that you have to find out the L. So you can, by using L by D ratio, you can find out the L value. Here the range is 1.2. So in general you can take the mean value around 1.6. That means here L by D is equal to 1.6. Here L by D 1.6 we are taken. Okay, you can take 1.5 also. So not a problem. We are taking 1.6. Here D is the 0.1 meters. So now L by D. So from L by D, here L is equal to 1.6 D. Okay, so 1.6 into D value 0.1 meters. Then you will get the value to solve. Okay, that is 160 mm or 0.16 meters. You can solve using calculator. Okay, 1.6 into 0.1. okay, pause. Right. So L value, okay, that is 1.6 into 0.1, that is 0.16 meters or 160 mm. Okay, so L is over. Now you have to check the pressure, whether the pressure is within the safe or not. So they are given the maximum pressure 1.5 Newton per mm square. Okay, here you have to check with the given maximum pressure. So that for that you have to find out the pressure. So to find out the pressure, we have a formula. Okay, from that book, see here we have a formula, that is pressure P is equal to W by 2 into R into L. Okay, this is the bearing pressure. Okay, you can use that formula to find out the pressure, that is P is equal to W by 2 into R into L. So same formula you can write to W is equal to W by D into L. Here 2R means diameter. Here DL is the projected area. As you know, pressure is the ratio of load per area. Load per area. So this is the projected area. Okay, this is the, suppose if you project from this direction, okay, you will get the shape as rectangle. See, this is the projected area. So it looks like a rectangle. This is the length and this is the diameter. So here you will get like this. This is the projected area, one is D, other one is L. So here the projected shape is rectangle. So the rectangle area is D into L, that is DL. So this is the actual formula. So but the above formula is W by 2RL in the data book, that is 351 page from the Mahadevan data book. Okay, now we can solve. Here in the question they are given the W value 20,000 newtons, that is 20,000 newtons by DL. The D is, where is the D? They have taken already D value. Okay, that is 100 mm. The D is the 100 mm. Okay, you can take it in a meters, that is 0.1. From the above formula, W by DL, where W load is the 20,000 newtons and D into L, where D is the diameter, that is 0.1 meters, and L 0.16 meters. So from this you can find out the value as what is the value, that is 1.25. So then you will get the 1.25 into 10 power 6 Newton per meter square, nothing but mega Newton by meter square. As you know, 1 mega Newton is equal to 1 Newton per meter square, right? So the same value you can write 1.25 Newton per mm square, because the given value also in terms of Newton per mm square. Okay, now you can check with this value. This is the maximum value, permissible value. This is the calculated value. So you can say simply the pressure is within the safe range. That means the diameter and length are also in the safe range. So you can write the comment here, pressure is safe. So L and D also safe. Here you have checked the pressure and also checked the D and also L in safe or not. You have checked, right? Now you have to go for condition. You have to go for the condition. That means what type of lubricant, whether it is hydrodynamic or hydrostatic. So for that you have to find out the first bearing characteristic number, that is Zn by P is equal to BCN. This is the bearing characteristic number. Okay, so this value you have to find. Okay, right? So here this is the Zn by P value. Okay, first you have to find out the Zn by P value. Okay, that is, see here Z is the 0.017 and N is 900 RPM. N is 900 Zn, and P value, here you have to use the calculated value. Remember, calculated value, not given value. Okay, we have to use the calculated value, that is 1.25. Then you will get the value, that is 12.24. 12.24. This is the calculated ZNPV value. Okay, now we have to compare this value with K. Okay, where K is the 1/3 of Zn by P from data book. This is the Zn by P from data book. Okay, that means 1/3 of 29.01. What is 9.666? So now you have to compare these two values. So here Zn by P is greater than K value. So you can say that this is hydrodynamic condition with thick oil. Hydrodynamic condition with thick oil. Okay, so finally you got the hydrodynamic condition and with thick oil lubrication, because you get the ZNP is maximum compared to K. Here K is the bearing modulus. ZNP is the BCN, that is bearing characteristic number. Okay, these two may be asked in the short questions. Okay, what do you know about bearing modulus and bearing characteristic number? Okay, important concept. Okay, so here condition is over. Next we have to find out the heat generation and heat dissipation. Let us see the heat generation. You can refer the formula. This is the Mahadevan data book. Okay, this is the Mahadevan data book. Here we have a formulas. See, so here we have formulas for heat generation, that is Hg FWV, and this is heat dissipation HD Ka delta T. Okay, so you can use these two formulas. Okay, that is here Hg FWV. So here we have a formula, Hg is equal to FWV. Okay, where F is the coefficient of friction. Okay, here the same formula is available in PSC, that is mu WV. Okay, here for mu we have a formula that mu is the coefficient of friction from the Mackey's equation, that is 33.25 by 10 power 10. Here units are different, so you have to take 10 power 8 as per our units. Okay, 10 power 8, remember, Zn by P d by C plus K. Okay, where Z is the viscosity, N RPM, P pressure, d by C is the clearance ratio. Where d by C is the clearance ratio. Okay, see here from FWV formula. Okay, FWV formula, here F is the coefficient of friction. See, this is the Mackey's equation available in the Mahadevan data book. Okay, we observe these two formulas. Okay, in place of Ka we have to write 33.25 by 10 power 8, remember. Okay, here formula is not provided exactly. Okay, so Zn by P is same, R by C and D by C both are same. Here C is the clearance, diameter clearance. Okay, where D is the diameter. Okay, and in place of K, small k value, here we have a delta F value. Here we have to neglect this term. So delta F is equal to 0.002. Both are same. Here K, here delta F, both are same, 0.002. So better to use this formula directly. Okay, so directly use this formula. Here this is insufficient formula. Okay, if you want to use, you have to replace Ka with 33.25 by 10 power 8, and you have to neglect this term and replace the delta F. You have to replace with K, that is 0.002. Okay, let us take this mu formula. Okay, this is mu WV. Okay, where mu is equal to 33.25 by, see, you can refer this here, 33.25 by 10 power 8. Don't forget, don't write 10 power 10, you have to write 10 power 8. Okay, and Zn by P, Zn by P and d by C plus K. Okay, delta K or delta K or delta F is equal to 0.02 and d by C or C d by C or R by C, both are same. So this is the notations from the Mahadevan. These are the notations from the PSC data book. Okay. But here you have a C by R value, that is 0.0013. Generally in the original notation C by R1. Here, but here the notation is R1 is replaced by R. Okay. So you are taken directly 0.0013. You have to take the reciprocal value, that is R by C means 1 by 0.0013, same value. So here K is okay, D by C is okay, and Zn by P already you are calculated here, that is Zn by P value. So just we have to substitute directly. So mu is equal to 33.25 by, so calculated value. Okay, don't forget this value should be calculated value, that is 12.24, and d by C is the here 1 by 0.003. I can write directly 1 by 0.0013 plus small k here 0.02. So here you have to calculate this value plus and then add this value. Approximately you will get the 0.0051. Okay, this is the mu value. Now substitute this mu value in this equation, you will get the Hg, 8th generation Hg. This is symbol is Hg. Okay, Hg is equal to mu W V. Here where V is the 5D by 60. Remember this formula. This is similar for belts and gates and bearings. For all the elements the formula is same, that is 5D by 60. Remember. Okay, here mu is 0.0051 and W 20,000 newtons, and V here W value is 20,000 newtons, and we have to take, let us calculate here, V is equal to 5dN by 60. The V should be always in meter per second, so you have to take V is equal to 5, D should be in meters 0.1 and N 900 rpm by 60. See here you can check N value 900 rpm. Okay, right. So then you will get the V value, that is V is equal to 4.71 meter per second. Okay, then same value you can substitute here, 4.71. Then you will get the Hg value around 480.7 watts. As of now Hg is over. Now you have to find out the next one, Hd. Hg is over. Okay, now you have to find out the Hd. So let's see. Here the formula for Hd is equal to, see here from the above, Hd K A TB minus TA. Okay, I have taken KH is there, I have taken K only. H is the KH is the H indicates heat dissipation coefficient. Okay, that's why KH. Or you can take directly KH. So here also you can replace that value with KH. Here where it is here KH, heat dissipation coefficient. Okay, KH. So that is KH A and TB minus TA. TB minus TA. This is the same formula I have taken here. Okay, but here TB and TA not given directly. Repeat. So here TB minus TA is equal to half of TO minus TA. Okay, so because here TB is the bearing temperature, is not given directly, so that's why we have taken TO and TA, because they are given TO TA directly. So directly I have replaced the TB minus TA value with KH into A. In place of TB minus TA, I have replaced with half of TO minus TA. I have replaced with half of TO minus TA. Okay, now you have to substitute all the values. Here you know already KH value A. A is the project area. L into D. Here already discussed. L into D is the project area. Okay. And TO minus T are given directly. So you have to substitute. See. So here the KH value is 123 watt per meter square degree centigrade. The value is in terms of meter square. And after the area. So area, as you know, product of L into D. So L into D, rectangle area, project area. So it should be also in meter square, half of TO minus TA. That's why I have taken KA in meters square area. So L into D, both are in meters, and half of TO minus TA, where TO 55 and TA 15.5 I have taken directly. After that you will find the value, that is 389.3 watts. Okay. Now check. So here HD, heat dissipation is over. Next you have to check the artificial cooling, whether the cooling is required or not. So for that you have to check the difference. If the difference is 0, that means both are same. Heat generation, heat dissipation is same. That means there is no artificial cooling. The difference is having some value. Definitely artificial cooling is required. So here also you have to find the value. So check for artificial cooling. That means you have to find out Hg minus Hd. Here Hg value, that is 480.7 minus HD value here 389.3. So this one 91 ಹೆಸರಿದೆ ಚಿಂತೆ ನಾನು ಮದುವೆ చేయట్లే ಓಕೆನಾ. And so here we have the 91.4 watts. That means we are having some value. So definitely we need some artificial cooling. So you have to write comment. Artificial cooling is required. You have to write the comment like that. So as per design process, the problem is over. But design general bearing means as up to now information is sufficient. But they are asking additionally find out the mass. That means mass of the cooling water or the cooling oil required. So for that you have to take the formula. Hg minus Hd is equal to mCp delta T. Okay. So here you have to find out this m value. You know already this difference. Delta T also given, but Cp value is not given. So here you have to take Cp value. Let us assume. Okay. Here you have to assume Cp value is 1.9 kilojoule per kg Kelvin or 1900 joule per kg Kelvin. Okay, generally as you know we have Cp value 2.1 kilojoule per kg Kelvin. You are taking 1.9. You can take 2.1 also. Let us take 1900 joule per kg Kelvin. Okay, so then you will get 91.4 is equal to m into Cp 1900 into delta T, that is 10. After then you will get the value from this. The mass is equal to 0.0048 kg per second. This is the mass of the cooling oil required. This is in terms of seconds. If you want in terms of minutes, okay, if you want in terms of minutes, multiply this value with 60, then you will get the m value 0.288, that is kg per minute. So this is the mass of the oil required in terms of minutes. That's it. Okay.